This code installs the PyAlgo trading and TALib libraries, which are used for implementing algorithmic trading strategies and analyzing technical indicators in the financial markets. The PyAlgo trading library provides a framework for backtesting and live trading strategies, while TALib is a popular technical analysis library that provides a range of functions and indicators for assessing market trends and conditions. By installing these libraries, the code prepares the necessary tools for implementing an algorithmic trading system. This code is part of an algorithmic trading system that plots technical indicators on charts. First, it imports the necessary libraries, namely pandas for data manipulation and talib for calculating technical indicators. It also imports the broker connection 0 class from a custom module called broker_connection_0 and the plot_candlesticks_chart and plot type functions from another custom module called func. The code is likely to perform further operations utilizing the functions and classes imported. However, without the full code, it is difficult to provide a more detailed explanation. This code initializes an API key and API secret for a broker connection. It uses the broker connection 0 class from an external library. The API key and secret are required to establish a connection with the broker's trading platform. The specific name of the broker and further functionality of the code is not provided in the given snippet. This code is used in algorithmic trading to plot technical indicators on charts. The request_token variable is set to a specific token that is provided by the user. The broker_connection object is then used to set the access token to the value of the request token. This access token is necessary to establish a connection with the broker and retrieve data needed to plot technical indicators on charts. This code retrieves the instrument data for the Stochastic from the National Stock Exchange, NSE. The historical data for this instrument is then fetched for a specific time period between January 1, 2020, 12 p.m., and January 1, 2020, 2 p.m. The historical data is stored in the variable historical_data for further processing and analysis. This code calculates the simple moving average, SMA, with a time period of 9 for a given historical dataset. The close column of the historical data is used as the input parameter for this calculation. The result is stored in the variable SMA_9. This code defines a list called indicators which contains information about a specific technical indicator called SMA9, simple moving average with a period of 9. The indicator's data is stored in the variable SMA_9 and additional information about the indicator's appearance on a chart is provided in the extra dictionary. The code then calls a function called plot_candlesticks_chart with various arguments including the historical data, the type of chart to plot, Japanese candlesticks, the list of indicators, and a caption for the chart. This function likely generates a chart that displays the historical data as candlesticks and overlays the SMA9 indicator on the chart. The chart is specific to the stock symbol NSE, .steel and covers a particular time period, 1 Jan. 2020, with the candle interval of 1 minute. This code calculates the exponential moving average, EMA, of a given dataset. The dataset used here is the close price from historical_data. The EMA is calculated using a time period of 9. The calculated EMA values are stored in the variable EMA_9. This code is part of an algorithmic trading system that plots technical indicators on charts. The code creates a list called indicators that contains information about the indicator to be plotted. In this case, the indicator is the exponential moving average, EMA, with a period of 9. The code also specifies the color and style of the line used to plot the indicator. The code then calls a function called plot_candlesticks_chart and passes it the necessary parameters, including historical data, the type of plot, in this case, Japanese candlesticks, the list of indicators, and a caption for the chart. The function will use these parameters to generate a chart that shows the historical data, with the M9 indicator plotted on top. This code is computing the MACD, moving average convergence divergence, technical indicator for a given dataset of historical stock prices. It uses the values of the close column from the historical data. The MACD indicator is calculated using the fast period, 12, slow period, 26, and signal period, 9. The resulting MACD line, signal line, and histogram values are stored in separate variables. These computed values are then used to create a pandas data frame, where the columns are labeled as line, signal, and histogram, respectively. The data frame contains the corresponding values for each indicator. This code creates a list called indicators which contains dictionaries. Each dictionary represents a different technical indicator and contains the name of the indicator, the data associated with it, and additional properties such as the mode of plotting and the line width. After that, a function called plot_candlesticks_chart is called with various parameters such as the historical data, the type of plot to be used, the list of indicators, whether the indicators should be plotted separately, a caption for the chart, and the desired plot height. This function likely takes this information and generates a candlestick chart with the specified indicators plotted on it. This code uses the Taleb library to calculate the parabolic stop and reverse, PSAR, indicator for a given set of historical high and low prices. The SAR indicator helps traders identify potential reversal points in a market trend. It takes into account the acceleration and maximum parameters to adjust its sensitivity and indicate potential stop and reverse points. The calculated SAR values are stored in the SAR variable. This code is creating a list of indicators for plotting on a candlestick chart. The first indicator in the list is called SAR and it contains the data for the indicator. It also has some extra information such as the mode, line style, dash, width, and color. The code then calls a function called plot_candlesticks_chart with the historical data, plot type, indicators list, and a caption as parameters. This function is responsible for plotting the candlestick chart with the specified indicators and caption. The caption includes information about the trend indicator, stock symbol, date, and candle interval. This code calculates the relative strength index, RSI, for a given set of historical data. The RSI is a technical indicator used in algorithmic trading to identify if a security is overbought or oversold. In this code, the RSI is calculated for the close prices in the historical data, with a time period of 14. The result of this calculation is stored in the variable RSI_14. This code creates a list of indicators, where each indicator has a name, data, and extra information such as mode and line properties. Then it calls a function called plot_candlesticks_chart to plot a candlestick chart using historical data. The function takes in parameters such as the data to plot, the type of plot, Japanese candlesticks, the list of indicators, a Boolean value indicating whether to plot the indicators separately, and a caption for the chart. This code uses the Taleb library to calculate the slow stochastic oscillator, STOC, indicator for a given set of historical data. It takes the high, low, and closing prices from the historical data and calculates the slow K and slow D lines using the specified parameters, fast_period, slow_period, slow_matype, slowed_period, slowed_matype. The resulting slow K and slow D values are then compiled into a pandas data frame with the columns slow K and slow D. This code defines a list of dictionaries called indicators. Each dictionary represents a different indicator to be plotted on a chart. Each dictionary has a name, indicating the name of the indicator, a data key, referring to the data to be plotted, and an extra dictionary which contains additional information about the plot, such as the mode and line width. The code then calls a function called plot_candlesticks_chart with several parameters, data, referring to the historical data to be plotted on the chart, plot_type, indicating the type of chart to be plotted, in this case, Japanese candlesticks, indicators, passing in the list of dictionaries created earlier, plot_indicators_ separately, a Boolean indicating whether to plot the indicators separately from the main chart, caption, providing a caption for the chart, and plot_height, setting the height of the chart to 700 pixels. Overall, this code is used to plot a candlestick chart with additional technical indicators, such as the slow K and slow D, and customize the appearance of the chart. This code uses the technical analysis library, Taleb, to calculate the Bollinger Bands indicator for a given historical data of closing prices. Bollinger Bands consists of three lines, the upper band, the middle band, and the lower band. The upper band is calculated by adding two standard deviations to the moving average of the closing prices. The middle band is the moving average itself, and the lower band is calculated by subtracting two standard deviations from the moving average. The code then creates a pandas data frame with the calculated upper band, middle band, and lower band as columns. Creates a list of indicators, including upper band, middle band, and lower band, with corresponding data and styling properties. The indicators are then passed into a function called plot_candlesticks_chart, along with other parameters such as the type of plot, historical data, and a caption. This code is a part of an algorithmic trading program that is used for plotting technical indicators on charts. The code calculates the average true range, ATR, indicator with a time period of 14. The ATR is a measure of market volatility, and it is calculated based on the high, low, and close prices of historical data. The variable ATR_14 will store the calculated ATR values. This code is adding an average true range, ATR, indicator on a candlestick chart for a specific stock, NSE, Tata Steel. The ATR indicator calculates the volatility of the stock based on its price movement. The indicator is plotted separately from the candlestick chart and is customized to have a purple line with a width of 2. The chart is generated based on historical data for the specified stock and has a specific caption and height of 700 pixels. This code calculates the unbalanced volume, OBV, for a given set of historical data. OBV is a technical indicator used in trading to predict price trends. It is calculated by adding the volume on days when the price increases and subtracting the volume on days when the price decreases. The resulting OBV values can be used to analyze the buying and selling pressure in the market. This code is using the algorithmic trading library to plot a candlestick chart with a technical indicator called unbalanced volume on it. The indicator data is stored in the OB variable. The indicator is plotted as a line with a width of 2 and a purple color. The chart is generated using historical data provided in the historical_data variable. The chart type is set to Japanese candlesticks. The chart is set to plot the indicator separately from the candlestick chart. The chart is given a caption and a height of 700 pixels. This code defines a function called VWAP that calculates the volume-weighted average price, VWAP, based on historical data. The function takes an pandas data frame called hist_data_df, which should have columns for timestamp, high, low, close, and volume. Inside the function, the timestamp column is converted to date format and stored in a new column called date. The unique dates in the dataset are sorted and stored in the variable unique_dates. Then, a loop iterates over each unique date. For each date, a subset of the data frame is created that includes only the rows corresponding to that date. The typical price for each day is calculated as the average of the high, low, and close prices. Using the typical price and volume columns from the subset data frame, the VWAP for that day is calculated as the cumulative sum of typical price volume divided by the cumulative sum of volume. The VWAP for each day is stored in a list called VWAP_day. Finally, the VWAP values for each day are concatenated together into a single pandas series called VWAP, which is returned by the function. This code is creating a variable named VWAP and assigning it the value of the volume-weighted average price, VWAP, calculated using historical data. The VWAP is a trading indicator that calculates the average price at which a security has traded throughout the day, weighted by the trading volume at each price level. The VWAP historical_data part of the code suggests that there is a function called VWAP that takes the historical data as an input and returns the VWAP value. The actual implementation of this function is not provided here, but it can be assumed that it follows a specific formula or algorithm to calculate the VWAP based on the provided historical data. By assigning the VWAP value to the VWAP variable, this code allows further operations or analysis to be performed using the VWAP data. This code defines a list called indicators which contains a dictionary. The dictionary has a key-value pair for the name of the indicator, VWAP, and a key-value pair for the data associated with the indicator, VWAP. It also has an extra key that contains additional information about the indicator, such as the mode of plotting, lines, and the line properties, width, 2, color, purple. The code then calls a function called plot_candlesticks_chart which takes several arguments including the historical data, the type of plot to use, Japanese candlesticks, the indicators to plot, and various other parameters like the caption and plot height. The purpose of this function is to plot a candlestick chart with the historical data and overlay the specified indicators on it. The resulting chart will display the volume-weighted average price, VWAP, indicator for the specified stock, NSE, .steel, on 1st of January 2020, with the candle interval of 1 minute, and a plot height of 700 pixels.